Good afternoon, Robert Scribbler. It is August 17th, 2018. Thank you for joining me for another climate change and clean energy video blog. Now for this segment, I am going to talk about how climate change in one way has notably disrupted this year's summer weather patterns, and in particular how this pattern of climate change is disrupting Northern Hemisphere weather more and more often. But before I get into that, I would like to drop a few heavy-hitting scientific names who have been increasingly reporting on this subject. And those names include Dr. Stefan Rahmstorf, Dr. Michael Mann, Dr. Jennifer Francis, and I hope I get this pronunciation correct, hold on, Dim Kumu, among many, many others. And what these scientists are saying is that, and I've talked about this before a number of times, but I want to just put a very fine point on the fact that it's just not me saying this, it's not just Dr. Michael Mann saying this, it's not just Dr. Stefan Rahmstorf saying this. This is a growing body of research coming from numerous scientific voices that are extraordinarily reputable. These are not climate alarmists or climate doomers, as I like to call them. These are very serious scientists who have conducted very serious research about a crisis that is now ongoing in the Northern Hemisphere. So basically what's happening, and there are a number of other factors involved, but to just drill down to the basic physics of the matter, is that warming at the pole and a number of warming-related feedbacks coming from systems such as reduced sea ice and changes to the albedo of land masses, or the reflectivity of land masses, is causing the pole to become warmer relative to the equator. And this is resulting in a wavier jet stream pattern in which ridges and troughs tend to dominate. Now, back in March of 2017, Dr. Michael Mann put together a study on this issue, and the study talked about how extreme weather events were linked to climate change's impact on the Northern Hemisphere jet stream. And at that time, I wrote an article on my blog page entitled "A Halo of Storms and Heat Waves." And that's basically what sea ice loss, according to this research, causes. And it helps to influence the jet stream in such a way that you end up with a pattern in the Northern Hemisphere, sometimes during summer, and we've seen it during this summer, where you have basically a band of a halo of heat waves and extreme storm zones interspersing the Northern Hemisphere. And this particular visual is from May of 2013. And I'm sure we're going to see some research based on the summer of 2018, because the summer of 2018 has been quite extreme, both in the North American region and in Europe, and there are a number of climate change related signals that are impacting the jet stream at this time and influencing the extraordinary warm and extraordinary stormy weather patterns that we have experienced during this period. Now, I'd like to call your attention to an article by Dr. Stefan Rahmstorf in Politico, which was published in Europe, entitled "Europe's Freak Weather Explained." And this is written by Dr. Stefan Rahmstorf. I'm just going to pull a couple of quotes from this article and a couple of notes from this article. I encourage you to read the whole thing, please, not just the title or the first paragraph. I'm gonna just move along and note that for the location of Potsdam that Dr. Stefan Ramsdorf is talking about, the average temperature departed by 4.3 degrees from April to July, and so you ended up with a major excursion on the side of warm. And what Dr. Stefan Ramsdorf is saying is that these extreme jet stream patterns, and we've observed a very strong ridge in Europe throughout from May through July, has influenced these temperature extremes that Europe is now experiencing. And so, and what Stefan Ramsdorf here is saying is that, though climate change is influencing peak temperatures, it's also influencing baseline temperatures. And I'm going to read a quote here. A naive way to estimate the contribution of climate change to the high temperatures goes something like this. The smooth curve shows the effect of global warming, and the scattering of the gray bars around this curve is the random variations of the weather. Accordingly, slightly more than half of the 4.3 degrees would be due to global warming, the rest to weather. That's not a bad first estimate, but it likely underestimates the contribution of climate change. Not only is the current outlier by far the biggest, there is growing evidence that the rest of weather is not just random, but has already been altered by climate change too. And it's here that we get back to climate change's influence on the jet stream. If climate change is altering the Northern Hemisphere jet stream, it's not just altering the Northern Hemisphere jet stream for hot events. It's altering the Northern Hemisphere jet stream for extreme weather and cold flash events as well. And in one instance, I'm just going to look at one instance here. Well, before I do, I just like to say, so we've got this influence due to polar warming and polar amplification, which influences atmospheric circulation patterns upstream. But what's also happening are regional effects, and in particular for Europe, there's this issue of a cold pool in the North Atlantic. And this cold pool is a persistent feature, one that we see year after year after year, regardless of what oscillation phase the North Atlantic is in. So it might fade a little bit and it might flare a little bit, but we see this. And this cool pool, which is the result primarily of Greenland melt and other factors related to human-caused climate change, but freshwater melt is the primary contributor to this cool pool. What this cool pool does is it tends to generate a trough pattern in the North Atlantic, and during summertime, a facing ridge pattern for Europe. And this tends to influence extreme weather in Europe in the summertime. But it also has some knock-on effects. You can get these very deep troughs that kind of move into Western Europe from time to time, and you see these hard swings from hot to stormy. And so this feature would not be here without the warming that the globe has experienced. And this is one of the features that Dr. Stefan Ramsdorf talks about in his article. So as you read articles like this by Dr. Stefan Ramsdorf, I'd like to just call your attention to the past science that has already been done by numerous scientists. This is not just Stefan Ramsdorf shouting out in the woods here. This is Stefan Ramsdorf and Dr. Jennifer Francis who first alerted us to this potential, and numerous other scientists who are providing a solid set of observational and research data that supports this new change to Northern Hemisphere weather influenced by fossil fuel burning and polar amplification due to the accumulation of greenhouse gases in our atmosphere. So please look at the science, please listen to the scientists, follow Dr. Mann and Stefan Ramsdorf on Twitter, and the others too. So yes, this